For over a decade, Android development revolved around a specific loop inside Android Studio. You write code, you run it, you debug, and repeat. This traditional workflow provides structure and speed, but it also creates a dangerous illusion, the belief that the actual process of development is contained entirely within that local environment. In reality, every time you ship a feature, you are interacting with a massive surrounding architecture. You are touching CI/CD pipelines, analytics, APIs, backends, and external design tools. These surrounding tools are no longer passive endpoints. They are becoming programmable systems of their own. The IDE is merely a terminal viewing a much larger automated network. Scaling modern development requires moving beyond this IDE-centric model. To interact with the Android environment, we historically relied on unstructured text and manual command line inputs, typing commands like adb loncam or /gradlew assemble debug. This approach is fragile. Text output requires a human to interpret the results, and relying on terminal commands acts as a bottleneck that prevents automation from scaling. The architectural solution is a shift toward Android skills. This changes how the operating system communicates with external tools. Raw terminal commands map to hard-coded coordinates. Now, these transition into structured JSON blocks, where targets and actions are explicitly defined. Instead of tapping specific pixels, it targets the checkout button directly. You define the desired outcome. The system manages the execution steps. Structuring capabilities into machine-readable JSON is the prerequisite for removing the human from the execution loop. Once these structured capabilities are exposed, external tools can interface directly with the operating system without manual developer intervention. AI tools and CI pipelines act as agents. These agents orchestrate the Android environment by passing a JSON payload in and receiving structured telemetry in return. Through this loop, agents trigger builds, simulate user flows, and inspect UI hierarchies autonomously. Previously, these tasks required a developer to manually navigate the IDE, clicking through menus and reading logs to identify and debug issues. Through agent orchestration, Android transitions from a developer-driven platform to a system-driven platform. However, automated interaction relies on predictability. Agents operate on logic. If they encounter an unstructured or dynamically shifting interface, the automation fails. Without standardized UI naming conventions, automation breaks down. The system cannot reliably identify or interact with elements that lack a consistent structure. Strict design systems, using standardized tokens, components, and patterns, provide the necessary structure for these automated systems. This mapping illustrates how Jetpack Compose makes these design tokens code-native. This consistency provides the predictable mapping an agent requires to confidently locate and interact with interface elements through Android skills. In a programmable system, a design system provides the structural integrity required for machine-led interaction. Even with automated agents, manual interpretation of static design screens creates a gap in the pipeline. The Model Context Protocol, or MCP, addresses this by evolving Figma from a drawing tool into an active data source. MCP translates visual UI updates into structured, machine-readable, and queryable data. In this sequence, a designer updates a component, the MCP exposes that change as structured data, and an agent reads it directly. The agent then uses Android skills to autonomously execute that design update into the Compose codebase, removing the need for manual translation by a developer. MCP transforms design into a live, queryable input that directly drives system behavior. This diagram connects these tools into a unified architecture. Figma intent flows to the MCP layer, passes to the AI agent, triggers Android skills, and executes in the UI. Application state and metrics feed bidirectionally back to design, replacing static mocks with direct synchronization. Development has decentralized, moving from an IDE bottleneck to a continuous, autonomous circuit. Operating this circuit requires a mindset shift. Engineers move away from writing instructions for individual screens and toward defining overarching system capabilities. If a system cannot programmatically interact with an app, that app cannot scale in this ecosystem. AI tools and agents are not replacements for the developer. They are force multipliers that execute the developer's intent at scale. The goal is no longer asking what tool replaces Android Studio, but understanding how to orchestrate programmable systems that build apps of the future.